we are going to discuss two examples on how to find the equation of a line. In our first example, we have a graph given on the Cartesian plane, and in our second example, we'll determine the equation of a line between 2 points. And as always, remember to like the video and subscribe to the channel for more videos like this. Let's move on to our first example. Here we have a line on the Cartesian plane, and we are given the y-intercept and the x-intercept. The y-intercept is equal to 4 and the x-intercept is equal to -6. And what we want to do is find the equation of the line in the form of y is equals to mx plus c. And in order for us to do that, we need to find the gradient of the line and the value of the y-intercept. In our previous videos, we discussed what the y-intercept is. It is the point where the line meets the y-axis. And for this example, the y-intercept is 4 because the line is passing through the value of y equal to 4. Please note, if you have had the coordinate instead of the point, you will not use 0, but you would read the y-intercept as the y value of 4. Now we have the y-intercept, and we now want to find the gradient. And for the gradient, we need the gradient formula. To use the gradient formula, we need two coordinates. And what we can see on our graph, we have the value of 4 and -6 that was originally given. And when we have a value on the y-axis, which was 4, the x-coordinate would be equal to 0. And on the x-axis, we have a value of -6. And the y values on the x-axis are always equal to 0. Now I simply need to choose my y1 and x1 values and my y2 and x2 values. You can use any of these points as your point 1 and point 2. And remember how to substitute correctly into the gradient formula, as explained on a previous video. So for y1, we have the value of 4 and y2, the value of 0. So we will have 4 minus 0 in the numerator. And x1 is 0 and x2 is -6. And when I substitute, I have 0 minus -6. Remember that we are subtracting the value of x2. And the value of x2 is -6. That's why we have a double negative. So if I simplify, I have 4 in the numerator and +6 in the denominator. And remember, with fractions, you always want to simplify those fractions as well. So 4/6 is equal to 2/3. So now we have the gradient as 2/3 and the y-intercept equal to 4. And if I substitute those two values of 4 and 2/3 into the standard equation, I have the final equation of the line, which is y is equals to 2/3x plus 4. In our second example, we want to find the equation of a line between 2 points, D and E. So again, we have the standard equation, which is y is equals to mx plus c. And we need to find the y-intercept value and the gradient. Now we already have two sets of coordinates, and we can use these two sets to determine the gradient of the line. All that you need to do is choose your y1 and x1 value and your y2 and x2 value and substitute those values correctly into the gradient formula. So for y1, I have 4 minus 16, which is y2, over x1, which is negative 2, minus 2. And when I simplify, I have 20 in the numerator and negative 4 in the denominator. Remember, two negatives becomes a positive, so in the numerator I have 4 plus 16 over negative 2 minus 2, which is equal to negative 4. And as always, we must simplify. So 20 divided by 4 is equal to 5, and the negative will move to the 5. And now that we have a gradient of negative 5, we can partially complete the straight line equation by replacing m with negative 5. Next, we want to determine the value of c. And in order for us to determine the value of c, we will substitute values into x and y. Now you have two sets of coordinates. You can substitute any of these two into the place of x and y in order to find the y-intercept. But if you substitute y with 4, then you need to substitute x with negative 2. Alternatively, if you select point E, if you substitute y with negative 16, then you must substitute x with 2. So I'm choosing to substitute y with 4. That means that x would be substituted with negative 2, and I'm left then with only plus c. So if I multiply out, I have negative 5 times 2, which is equal to positive 10 plus c, and I can transpose the positive 10 to the left-hand side by changing it to negative 10 in order to find c. So I'll have negative 10 plus 4 is equal to c. Therefore, the y-intercept is equal to negative 6. And now that we have the two values of the gradient and the y-intercept, we can simply substitute those values into the original equation. So the gradient is replaced with negative 5, and the y-intercept is replaced with negative 6.